Hello. Today at uh, we'll be looking at logarithmic differentiation. Okay. So what is logarithmic differentiation? Okay. Logarithmic differentiation is a technique used to differentiate complex functions, especially functions which involving products, quotients, or power of functions. Okay, so when doing logarithmic differentiation, we have to consider the rules of log. Okay, we have to consider the rules of log. Okay, so what are these rules? Now, the first rule is saying if you have ln into f of x multiplied by g of x, this can be expressed as ln of f of x plus ln of g of x. Okay, so the multiplication is the one that is giving it the addition sign. Okay, so the second rule is saying for ln into f of x over g of x. Okay. This can be expressed as ln f of x minus ln g of x. Okay. And then we have the third rule. And the third rule is saying for ln f of x to the power n, this can be expressed as n ln f of x. Okay, so these are the rules that we'll be using to solve some of the questions that we'll do today. So let's work with an example so we can better understand how to do logarithmic diff. Okay, so let's say we have a function where we have to find dy dx, where we have y is equal to x log of x over square root of x minus 1 multiplied by tan of x. Okay, so we have to solve this function using logarithmic differentiation. Okay, so first thing you must do for logarithmic differentiation is to take ln both sides. Okay, so we have to take ln on the left hand side, which means we will have ln of y. Okay, we also have to take ln at the right hand side, which means we will have ln of the whole equation on the right hand side. Okay, so what do we have on the right hand side? On the right hand side, we have x log of x over square root x minus 1 tan of x. So how can we take the ln? We can say this is ln of x, which is the first one, plus ln of log x. Why? This is because the laws of log tell us for x multiplied by log x, multiplication gives us the addition sign. That's why we have ln of x plus ln of log x. Okay, therefore the division sign tells us we have to subtract. That's why we're going to have minus ln square root x minus 1. Okay, and then the last one also subtract minus ln tan of x. Okay, so now we have to simplify this equation so we can derive it easy. Okay, this means we will have ln y is equal to ln x plus ln log of x minus ln square root of x minus 1. So how can we simplify it? We know the square root is equal to the power 1 over 2. So this means we can have ln x minus 1 to the power 1 over 2 minus ln of tan x. Okay? And then now all we have to do is to derive both sides. So this side, what is the derivative of ln y? Derivative of ln y will be 1 over y dy over dx, as we are deriving y, equal to, what is the derivative of ln x? This will be 1 over x, okay, plus, what is the derivative of ln into log x, okay? This is like a chain rule. So we have to derive the outer part first, and then we derive the inner part. Okay. So what is the outer part? The outer part is ln of the inside. So this means ln of the inside will be 1 over the inside. And our inside is log of x multiply by the derivative of the inside. What is the derivative of log x? Derivative of log x, it's 1 over x ln of 10. Okay. So derivative of log x, there's a video that I already did. So I'll leave a link for the derivative of log x, how you find that the derivative of log x is 1 over x ln of 10. Okay. And then we go to the next one. Next one is derivative of ln into x minus 1 to the power 1 over 2. Therefore, laws of log to the power 1 over 2 has to come to the front, as the rules of logs tell us. Meaning we will have negative 1 over 2 multiplied by the derivative of the outside. Derivative of ln a number, ln the inside, derivative of ln the inside, which means we'll multiply by 1 over the inside, which is x minus 1. Okay? Multiply by derivative of x minus 1, it's 1. Okay? So we don't need to write that. And then our last one is derivative of ln into tan of x. So say derivative of ln a number, it becomes 1 over that number. Therefore, we'll have 1 over tan x multiply by the derivative of tan x. From the table of derivative of trigonometries, we know that the derivative of tan x is equal to secant squared of x. Okay. Yeah. So moving forward, we have to simplify everything so we can factor out dy dx. Okay, so we can say 1 over y dy dx is equal to 1 over x plus, we simplify this one, we'll have 1 over x ln of 10 log of x. Okay, and then the second one, we'll have 1 over 2 into x minus 1. Last one, minus secant squared x over tan of x. Okay, so now all we have to do is to factor out dy over dx, or we can divide by 1 over y. This means we will have dy over dx, it's equal to y into, multiplies everything, 1 over x plus 1 over x ln of 10 log of x minus 1 over 2 into x minus 1 minus secant squared x over tan x. Okay, so this can be your final answer. Okay, But then you can also simplify further, where 1 secant squared x over tan x. So we can simplify that one further. So let's see, how can we simplify secant squared x over tan x? Let's say we have secant squared of x. Okay, we have secant squared of x over tan x. Okay. From trig identities, we know, Kuri, secant it's equal to 1 over cos x. Secant x is equal to 1 over cos x from identities. Therefore, it means we will have 1 over cos squared of x as secant is squared over, and then we know tan x is equal to what? Sin x over cos x. Okay, now you just have to simplify further. 1 over cos squared of x multiply by, and then cos goes on the top, cos x over sin x. Okay, and then now cos x will cancel cos squared x, and then only 1 cos x will be left, which means you are left with 1 over cos of x multiply by sine of x. Okay, you are left with that. But then how can we play around with it? Okay, we also know that sine into 2x is equal to 2 sine of x cos of x. Okay, so let's take out let's remove the 2 from 2 sine x cos x. This means we'll have 1 over 2 sine into 2x is equal to sine x cos x. Okay, so now we just have to take this, substitute it there. Okay, this means that we will have, this will come down here, this 1 over half sine 2x. Okay, still we can simplify it more and more and more. Okay, let's keep going. This means we can simplify it by saying that 1 over 1 multiplied by 2 over sine 2x. Okay, this is coming from 1 over half sine 2 of x. This becomes 1 over 1 multiplied by 2 over sine 2x. Okay, this means we'll be left with 2 over sine 2x, and then we remove the 2, bring it to the side as it's the constant. This means we have 2 multiplied by 1 over sine 2x. Okay, but we also know that 1 over sine x is equal to cosecant of x. This means 1 over sine into 2x will be equal to cosecant of 2x. Therefore, our answer will be 2 cosecant of 2x. And this is our answer. So now we can take this answer and then substitute it on our final answer. So we can take 2 cosecant of 2x, and then we'll substitute it with the secant squared x over tan x. Okay, we can substitute it here. Therefore, we have 2 cosecant of 2x. That is our final answer.